This video is about some differences between using ECM for ship defense against missile attack in the Arctic theater versus blue water temperate theaters where there are obvious environmental differences. Now there are three types of ships that might operate in the Arctic. There are small patrol ships, military warships, and icebreakers, any of which might or might not be equipped with ECM. There are two so what points in this video. First, if you are operating a warship that's already equipped with ECM, review your tactics and techniques and protocols for Arctic operations. And if the ECM uses real-time feedback like a Jog Detector for cognitive jamming, then the Jog Detector needs to work in an Arctic environment. Second point, if you are operating ships that aren't equipped with ECM but need to be in an Arctic environment, this video outlines some points to consider. So here are the main points, speaking loosely for brevity. First point, inflatable decoys won't work if they're dumped onto ice, and neither will a speedboat-type persistent decoy. An airborne persistent decoy might work, but there will be special Arctic considerations. And if you're using rocket-launched decoys or chaff, then you can't depend on the ship to orient the launchers if ice restricts the ship's mobility or its speed. Second point, chaff might behave differently in Arctic conditions where there are unique features like high wind, cold, and snow. Third point, the ship's speed and maneuverability could be limited by ice, and that might hamper its response to a missile attack. If the ship is stationary or nearly stationary, it might require ECM to be effective for attack scenarios that are maybe impossible or at least unlikely in blue water conditions. Fourth point, the Arctic multipath environment will be different compared with a blue water engagement because of freshwater icebergs and raised ice pressure ridges made of frozen salt water and windborne loose snow and such like. And this will create special signal processing requirements for both the ECM and the missiles. Fifth point, the Long-Range Defense Early Warning Network, or DEW-line radars, are present in Canada's Arctic, and if they are in band for ECM, then both jammers and decoys need to recognize them and ignore them. So those are the main points. Let's continue. So think of a missile engagement as comprising three things: the threat, the defending ship, and the environment. And this video is about the effect of an Arctic environment on how we use ECM to fight the missile. There are two options to cause a missile to miss its target. The first is to throw something overboard to attract the missile away from the ship. That's called a decoy. Or to use an active onboard jammer to radiate those confusing signals to achieve the same thing. The advantage of using an onboard jammer is you don't have to throw anything overboard, so there are no resupply issues because you never run out of electricity to run the jammer for ship defense. So let's run down the list of differences for Arctic operations in a little more detail. Most of these points involve snow and ice, but Arctic ECM also has to work in blue water conditions since ice and snow aren't always present. Okay, first point, offboard decoys. If the ship is surrounded by ice, an inflatable passive decoy isn't an option. They are designed to work in water, they're designed to get wet, and they depend on the ship creating distance between itself and the decoy. And if the ship is surrounded by ice, that's out. And the same argument disqualifies a persistent boat-type surface decoy if ice is present. On the other hand, the ship could use rocket-launched active offboard decoys, or chaff, which is also rocket-launched. Chaff is. So these have to be launched in the right direction at the right times. And if the ship is stuck in ice, or if it has limited maneuverability, and if the launch tubes are fixed in position on the ship, then the countermeasure cannot rely on the ship orientation to point the launch tubes. And if the launch tubes are trainable, which means you could point them where you want to, then for Arctic operations, their range of motion needs to be rationalized with the worst case ship maneuverability and the worst case missile attack geometry. An airborne persistent decoy might work, but cold weather operation will certainly involve different limitations than apply for blue water engagement in temperate climate. Batteries are less efficient in cold weather, so maybe a fuel-operated decoy might be preferable. Resupply could also be an issue if there is no easily navigable path between the combat ship and the resupply ship. I mean, airdrop delivery onto ice is an option, but that brings new complications. Second point, chaff. Well, Arctic wind and snow conditions are different from temperate blue water engagement, so these have to be rationalized with the number of rounds that are needed for ship protection and the round placement. And in particular, be concerned about the differences in chaff bloom time and RCS versus time, and if the chaff is, for example, deployed in a blizzard. Also consider chaff cloud dispersal in typical Arctic wind conditions and in high wind conditions, which can occur. Third point, what if the ship is in ice? Well, if the ship is surrounded by ice, or if it's breaking a path through ice, then its maneuverability and speed will be less than it is in a blue and water engagement. During a missile attack, both the jammer and offboard decoys will have to be intelligent enough to compensate for limitations in ship maneuverability and speed, in as much as they affect the outcome of the engagement. A cognitive jammer would alter its behavior accordingly, and so would cognitive decoys. If the ship is stationary or nearly stationary, the missile's targeting information might be uncommonly reliable, which could translate to late turn-on seekers. And missiles that choose to turn their seekers on close to the ship are a big problem for an onboard jammer and also for decoys. Now, this might never occur in conventional blue water engagements. And if the ship location is well known by the enemy, and it's not moving, an intelligent missile might adaptively use icebergs or hummocky ice terrain to hide its attack until it's close, also resulting in a late effective turn-on. Fourth point, multipath. Multipath means signal reflections from nearby objects, including icebergs or mountains or the sea surface if there's open water, or snow, or the snow surface, or ice surface if there isn't open water. Now, obviously, the multipath environment for Arctic operations will be different from blue water operations, so expect it to create special problems for both the missiles and the ship, the ECM. There could also be ice or brine buildup on the jammer's radome. Now, the radome covers and protects the jammer's transmit and receive antennas, and if the radome is covered with salty ice, it will degrade the jammer's performance. Ice is very conductive, salt water is very conductive. And if the ship is covered with ice or brine, its radar cross-section will be different from temperate or blue water scenarios. Now keep in mind also that we're concerned about multipath for future threats at all frequency bands. Certainly X-band, which is 8 to 12 gigahertz, but also Ku band, which is 12 to 18 gigahertz, and Ka band, which is 26.5 to 40 gigahertz. And there is an angle deception factor. To cause a missile to miss a ship, the jammer has to send the missile in the wrong direction. And there are very few ways to cause a flight path error in a modern missile, particularly after it's acquired its target. One way is by offboard decoys, another way is by cross-polarization jamming. But in both cases, a jog detector can be used by a cognitive jammer to confirm that the ECM is working as expected. So what's a jog detector? A jog detector senses seeker antenna deflections caused by ECM by noticing a drop in the measured seeker power when the antenna deflection happens. This is one example of the real-time effectiveness feedback I referred to before. The trick, though, with the jog detector is that multipath also causes drops in measured seeker power, so the jog detector has to distinguish between the two. This means that in an Arctic jammer that uses cross-pole jamming, it needs a jog detector that's qualified for an Arctic environment, and that might mean a design that's different from a jog detector for a blue water environment. Okay, last point, Arctic background signal environment. Well, Canada's Arctic hosts the high-powered defense early warning radars that are called the DEW line, and they might be detectable by either the jammer or the decoys if they're in band for those systems. And if those radars are detectable, then the ECM systems would have to be intelligent enough to compensate, so countermeasures effectiveness is not diluted by unintentionally engaging those friendly radars. Now, in conclusion, to wrap this up, I'd say it's prudent to expect two things. Firstly, that the missile designers are aware of the special features of Arctic operations, and that their advanced weapons need to be able to identify and prioritize and track and hit targets in an Arctic environment. And second, that they have done tests and made plans for Arctic engagements. Certainly in the late 1980s, the US was testing cruise missiles over the Canadian Arctic because there was an agreement about that. So it seems especially likely that this was done and is being done by countries which have a native Arctic presence like Russia and China. They can do all the testing they need to. No international agreements are required. And if they're thinking about it, then it's prudent for us in the ECM community to be thinking about it also.